I'm going to full screen this presentation. Welcome everyone to our very first how-to webinar. So this is really exciting for us to get a group of our customers to into this series. It's a new series where we're introducing, where we're going to be talking about specific features about the Sumo Logic service. The very first topic is something near and dear to my heart as a customer success manager. We'll be talking about optimizing your search experience. My name is Latimer Luis, and I'm also joined by Mario Sanchez, who is our Director of Training. And Mario will be walking you through a demo at the end of this presentation. A few housekeeping items. You're all on mute at the moment and will continue to be muted until the end of the presentation. And we do that so that we don't get interrupted by random feedback or background noise. We will be sharing this presentation, both the recording and the slides, in a couple of days. So expect something in your inboxes before the start of the weekend. So what will we be talking about today? Well, we'll start off by discussing basic search structures. I'm going to point out some of the most important components of a query string. I'll discuss and set expectations related to search performance, and then I'll introduce you to some search optimization tools. And the search optimization tools we have available within Sumo Logic include field extraction rules, partitions, schedule views. Right, as I mentioned, Mario will then walk you through sort of our live environment to show you how these search optimization tools will come into play and how you can sort of envision them working in your own system. I'll also leave some time to answer your questions at the end of the presentation. I'm hoping to leave about 5 or 10 minutes for a Q&A session. But as you come up with some questions, please type them into the question box in the GoToWebinar panel, and Mario will be fielding that as I'm actually talking and presenting. If there are any unanswered questions by the end of the presentation, we'll make sure that we address them as part of the Q&A. All right, so let's dive right in. What does a basic search look like in Sumo Logic? Well, it's basically a bunch of keywords and operators separated by pipes that build on top of each other, right? So you can see the search syntax here. Everything before the very first pipe is actually is the most important part of the search. This is your search scope, right? It's a combination of metadata tags and keywords. And then from there, you sort of build on the query by adding parse statements, basically extracting fields and making sense out of your log data, applying filters on the fields that you just extracted, and perhaps also doing some counting and summing, and using our aggregate operators. You can also sort and limit your data, so you're seeing the top 10 or top 20 results. Okay, this is an example search below. Many of you on the call are intermediate and advanced users, so I'm sure this isn't your first rodeo. So what are metadata fields? Well, they're essentially proverbial sticky notes that are slapped onto every message that Sumo ingests. These are the 5 types of metadata tags that we have. Collector, source host, source name, and source category. I won't go through each one of these and what they do, but I do want to point out that source category is the most important out of these 5 metadata tags, simply for the fact that it allows you to search horizontally across all of your messages. Okay, so similarly grouped messages could be searched pretty easily using source category rather than doing applying a search string where you're calling a bunch of different collectors, where you're saying collector A or collector B or collector C. You can bunch all of those collectors up into a single category and just call that category as part of your search. All right. Creating a good source category naming convention is absolutely vital to your success. And I want to stress this. We actually posted a blog on August 27th called Good Source Category, Bad Source Category. One of our professional services members had posted this with hopes that it'll drive people to come up with a better source category taxonomy. And once you get a copy of these slides, please, please, please go back to this slide and click on this link. I promise you it'll be worth the read. Okay, so on top of metadata tags, you can also use keyword searches to limit your scope. What is supported with the keyword search? Well, first of all, they're case insensitive searches. So in the example that I have on screen here, where I'm applying a keyword called get, it's all capitals. However, it'll search through all your data, and even any words that are in lowercase will be found. It also supports wildcards, right? So I could do an ERR star and get a list of errors. It supports Boolean logic as well. So I can get pretty sophisticated and put a lot of and, or, plus not statements, right? So this exclamation mark is actually a not operator. And to reiterate, these keywords can be combined with metadata fields to further reduce the number of messages that you'll be working with. Bloom filters, well, what are those? Well, they essentially allow us to locate your data very, very quickly. And by using keywords, it'll trigger sort of these Bloom filters to take effect. So how does Sumo Logic actually process your search? So what I have on screen is actually exclusive to this webinar. So for those of you joining, this is for your eyes only. This is not something publicly documented, but I think it's important for us to really call this out to help you understand what happens in the back end. So the first thing that we try to do when you write a search or send a search request is we try to rewrite your queries automatically. And we say automatically because we don't let you know that we're doing it, right? And not every query is subjected to query rewriting. Some of the things we do is we bring forward some of your search strings, your parse anchors, and if we are able to determine that a partition exists with the same scope that you're using, then we'll use that partition. Okay, once the query is rewritten, then Sumo Logic service basically calls a bunch of backend clusters to kick off the request. We then try and locate the indices that contain data for search time range, for the search time range that you've applied. Bloom filters, as I mentioned earlier, will further eliminate data or indices where keywords are not contained, right? So basically what it does, it removes false negatives, excuse me. So in the end, we're only left with the indices that do contain those keywords that you have. Okay. After that data reduction is done, then we basically retrieve your data. Everything through the first pipe is retrieved and is carried forward to the remaining set of operations. While the remaining operations are being conducted, we look for opportunities to parallelize the operations. So if you're using like sum and count operations, we'll look for ways to use what we call MapReduce in the background, right? For those of you who are familiar with big data analytics, we are going to be able to process your data in multiple streams. And then at the end of the processing, we'll again collect the data together. And because we're sort of processing these streams in parallel, it will further enhance and further improve the query search time for us in the back end. Okay, so let's talk about some search performance expectations. And in this section, what I want to talk about is what are some of the things that affect performance that are not directly related to the tools that can help you improve performance? And the first thing is developing good search habits. So we really think it's vital for you as users to create the proper syntax in the queries that you're executing, and to use metadata and keyword combinations to reduce the scope. When you're creating searches, also add line breaks after each operation so that they're easier to read. Now, this isn't necessarily going to affect the performance or the speed of the search, but if you're sharing that same query and publishing it so that your peers and team members can see them, then it just helps them understand what you're trying to do in that search, right? So add line breaks, make your search more legible. You also want to limit results before actually aggregating your data. So for example, here on the right-hand side, if you're looking for a specific user, filter the data by that user before you're actually counting the number of results. If you did it the other way around, where you had count by user and then you did, where user is equal to A, then your searches would be a little bit slower. Okay. Use parse anchor instead of parse regex for structured messages. So what's parse anchor again? Well, it's that nifty little UI that allows you to highlight a specific part of the message and then extract fields out of those messages. Right. Parse regex uses regex format to find very specific components within a log event. Okay. When you do use parse regex, you want to avoid very expensive tokens like .star, right? You don't want to look at everything to try and find where a field exists. You want to really specify, okay, so this field exists where there is a digit that's 2 to 10 characters in length somewhere in my logs. And lastly, you want to narrow your time range down as much as possible. Try not to search for the last 30 days of data if really what you're looking for is contained within the last day or so. And that brings me to the time range effect. More recent data can actually be accessed quickly. We actually do something very special for searching across the last 24 hour of events. Just to let you know, we basically use premium AWS EC2 instances to process these requests that are sort of beefed up with tons of compute power and solid state drives, which is why the queries for the last 24 hours will return really, really quickly. And the reason we do this is because over 90% of the queries that are executed in our system actually searched on recent data or very recent data, which makes this second point just as important. You want to test queries for very recent data first before you actually save them or publish them to others. So with respect to time, as you know, when you're setting up your collector, there's a portion of it. There's a portion in the setup process that allows you to specify your time zone setting. If this is incorrectly set, it can lead to a large gap between message time and receipt time. You can see the time zone setting here on screen in the screenshot that I have. Okay. And this large gap between message time and receipt time actually causes what we call data fragmentation, which ultimately can affect your search speed because we're trying to find data across disparate sets of indices. And it takes a little longer to process it when the message time and the receipt time for a particular message is shown to have a large gap. So one thing to note is that we support Java 6 time zone formats. So the first two bullet points or sub-bullet points here are things that we would expect in your log messages to have. If not, then we will fall back to the time zone setting that you've selected. Please note that US/Pacific is not a supported time zone, right? So if we find that in your logs, it will not be noted or it will not be recognized, as a valid time zone. And therefore, it will fall back to this time zone setting. And if this time zone setting does not match with what's in the logs, then that's where this problem can occur. All right. Aside from the search speed, data integrity will be questioned by your users as well. People are going to be searching over the last 15 minutes, but aren't finding the messages that they expect. Right? One thing I'll do when I send a copy of this presentation and the slides is I'll also provide you a link with a knowledge-based document that will walk you through how you can uncover where these gaps may be occurring in your own data sources. So not all operations are built the same, right? Some operations are more compute intensive than others. And I'm not suggesting that you can't use the operations that you see on screen here, but just be conscious that it'll add additional time to execute the search because of the computations that it'll have to do in the back end. Okay, we talked about very greedy parse regex tokens, and so you want to avoid having to use multiple dot star tokens in a single regex parse statement that you're building. If you are parsing the data and you're using one of our public libraries, consider rewriting those parse statements. And if you need help, we'll obviously, our team, the customer success team, will be glad to actually work with you to create the proper parse statement so that you're not utilizing some of these public libraries that we have available. Now, the public libraries like Apache Access, IIS, Windows 2008, these public parsers will work, except just note that it's basically each of these are comprised of 20 or so different parse statements, which is why if you use them, it will take a long time to really scour through your messages. Okay. Summarize, which is associated with our log reduce algorithm, is also a compute intensive operation because it's trying to find unique signature patterns across your log messages. One thing to note about join operations is that as you expand your time range using this operator, then the data return time will exponentially increase. With transaction, we actually allow you to limit the time window parameter for finding corresponding events. Okay, so please utilize that parameter. I think the default behavior is that you're looking for transactions that have occurred within 10 minutes of each other. Is null is an operator that I've personally found to be a bit slow when using. And outlier, which is one of our new operators. It has to actually go back and try to find average or rolling standard deviations and rolling standard and rolling averages. So that's why this particular operator is on the list here. All right, so I'm going to go ahead and jump into performance optimization tools. So what are these tools? Well, they're the bottom three options on the screen that you see here. So for those of you who are administrators, this will be available to you. A lot of what we'll be talking about in the next few slides will be mainly for those with administrative roles. For those of you who are, regular users or analysts of the app of the service, this may not be as pertinent to you. However, I think it's still important for you to stay on and understand, what are the ways that we can make search better so that you can communicate that back to your administrators and back to the people who manage your Sumo Logic service. Okay. So the three optimization tools that we have available are scheduled views, partitions, and field extractions. So how is data optimized for search? Well, when data is ingested, we apply field extraction rules first to basically pre-extract or pre-parse fields out of your log events. We then reroute data to partitions if you do have partitions set up in your environment. These are basically, we'll consider them separate tables that house data. Okay. Then our third tool, scheduled views, allows us to pre-aggregate the data. So if you're using, a lot of counting and summing in your searches, then they would be good candidates for scheduled views. After all of these components are created and all the data is rerouted, the data is indexed and is searchable through the queries, dashboards, scheduled searches, and all the mechanisms that rely on data in the service. All right, so let's talk about field extraction rules first because this is the first thing that gets applied. As noted, at the time of ingest, the fields are extracted and then can be leveraged across the product. Another benefit for field extraction rules is that it allows for standardization of searches and field names. So if one I would say one group was previously calling IP addresses source IP, and another group was calling them IP underscore addresses. You can sort of standardize that, right? And both groups would be using a single name. Okay, it allows you to simplify searches as well. So when you have field extraction rules set up, you can actually bring some of the things that we'd normally put into a where clause up to the front of your search. So you can combine your metadata tags and keyword searches with these new fields. And so if you're searching for Apache logs, for example, you can search for where the status code is equal to 404. So basically, allows you to really make searches easier for your users and should allow them to take advantage of some of the bloom filters that we have available. Field extraction rules will also improve search performance. It'll eliminate the need to sort of parse the data during query runtime, thus taking a lot of the processing power out of the equation here. When would you use field extraction rules? Well, when you have the same parse statement that's being used over and over, or a very similar parse statements being used over and over, right? So talk to your colleagues, check how they're parsing their data. What you may want to do is look at the searches that have been published and see if there's any commonality across the searches. And see if you could sort of condense all of those parse statements that people were doing into a single statement that could be applied to the same set of logs. Okay, if your users are filtering data based off of these parse fields. So in previous example, I told you about, I mentioned status code, right? If you're finding that people are doing a lot of filtering based off of status code, then you may want to parse that field. Another reason to use field extraction rules is where logs need to be tied together based on a unique ID, such as session ID, username, or process ID. And Where that may actually be used is where you're grouping data or counting by a specific set of data by one of these unique identifiers. And if you're parsing over a large volume of data, for example, the last 30 days, which could equate to over 1 million records, then you also want to consider using FERs, or field extraction rules. So how do you create one? Well, I showed you the manage screen. After clicking on field extraction rule and creating a new object, you'll be brought to a screen that looks like this. You'll provide it with a rule name, give it a scope. So this would be essentially the set of messages that would be applicable for this rule. Okay, and then you can type in your own parse expression or use one of our existing templates. Now you can also use the templates as a good baseline. So for example, if you have some custom Apache access logs, while you might not be able to use what we have out of the box, you could still you can still copy the parse expression over to this box here and then tweak it. But of course, one of the recommendations that we have is that you test these parse expressions in a search before you actually save it as a rule. Okay, so this is an example of how you would utilize one of the pre-parsed fields. So let's say you had a field extraction rule set up for Apache Access, and one of the fields that you're extracting is method. You can actually use that as part of your keyword search, as I mentioned earlier, right? You've got your metadata tag, and now this is part of your keyword search, where you're looking for where the field method is equal to get. Okay. You'll also notice that pre-parsed fields or pre-extracted fields are found in your field browser. So the left-hand side of your results represents your field browser. If you hover over any of these fields, you'll notice something really cool. You can see the distribution of the unique values for each of these fields. And you can see what sort of dominates your data. Right? In this case, the 200s and 304s in the sample data that I have made up a majority of the logs. So some recommendations: test a rule first by running a search over a small time range. Again, a small time range because you want to look at, you want to take advantage of some of the special things that we do for the last 24 hours. The scope and parse statement should not change. So when you're developing these rules, try to define something that you know is scalable. Ensure your field extraction rule covers some of the most common searches that are being executed. And again, I'm going to throw a plug in for our customer success group. If you guys don't know what you're searching for and sort of need help uncovering that, reach out to us, and we'll be able to tell you what your usage patterns are. Okay, and only extract the minimum fields necessary for the analysis that you're doing. To limit the fields, just use the fields operator as part of your field extraction rule, and define the set of fields that you actually care about. So even though you might be parsing out 20 fields, maybe you only want to run analysis or searches against 3 or 4 of them. And the reason for that is because there are a few limitations, right? We have a max of 50 total rules that can be built in the system, along with a max of 200 total fields across all of those rules, right? One thing to note is that deleted rules and fields defined will still count towards the max. Okay, so if you have 3 rules now, you delete them all, you'll still have 47 rules left to build. All right, so this is the list of supported operators. One thing to note is that JSON is not something that's supported yet. However, if your JSON object is very flat and sort of non-hierarchical, consider the use of regular parse statements or parse anchor statements. They'll still work on JSON, and sometimes it's just easier to parse data that way anyway. Okay, so those are field extraction rules. Now let's talk about partitions. So partitions divide your data into smaller chunks that can be searched on, right? Which means that similar data can be grouped together. So if you've got a bunch of web server logs, you can group those together, or Cisco um, firewall logs. And because they're sort of grouped together, it improves performance when you're actually searching against these partitions. So rather than searching across all of your data, you're only searching for maybe for less than 30% of your data. Okay, and because partitions are pretty flexible in how you can define them and the scope that you use, you can eliminate the need for lengthy scope definitions as part of the query that you're executing. So, for example, if you were previously doing, where source category is equal to Apache, or source category is equal to Nginx, or source category is equal to IIS, all of those could be bunched up into a single partition, right? And then you can search for where your partition name is equal to web server. Okay. It also takes advantage of some of the source category naming conventions that you guys will be developing. Again, I think the taxonomy of your source categories is something that you really want to pay attention to, and it'll make it easier for you to build partitions when you have the right naming convention in place. You'll want to create partitions where you have sets of data that are being searched in isolation. And that could be due to a few number of reasons. If you have a large amount of data that's being sent to us daily, so all of you are probably on different plans. If you're sending us more than 5 gigs worth of data a day, consider the use of partitions so that you can break the data into smaller slices and smaller subsets of messages. Okay. If you don't know how much data you're actually sending to us, navigate to the Manage drop down and click on the Account information. And this should give you a breakdown of how much data you're sending us daily in the current month and in the past month, and in the previous month, excuse me. Create partitions when different groups are focused on specific areas of your technology stack. Like, for example, if you have people that are focused only on your firewall, like security, right? Or if you have people that are only focused on the custom application that's being built. If you're utilizing RBAC filters, which are role-based access controls, you'll know that one of the things that are needed in order to create these RBAC filters is a query. And that query gets prepended to every search that runs for the user that fits inside a particular role. So let's say you had a role of QA engineer, right? You can assign a query for all QA engineers to be prepended. And that query may be, where your source category is equal to QA star. I'm just giving you like some sort of high level example here. But if you are using RBAC and these rules are in place in your environment, then you want to consider creating partitions based off of these rules. Okay. What are some of our recommendations related to partitions? Well, You want to use a combination, well, you want to use metadata tags for your routing expression, right? So let's say that you had a source category of QA, Web, Apache Access. Well, you can actually create partitions that would include this data in several different ways, right? If this data represents a pretty large portion of your total data volume, then maybe it belongs in its own source category, right? Or you could take the second approach where you bunch up all Apache logs together or all web logs together. But as you can see here, because I had a pretty good source category naming convention, it makes it really easy for me to determine what data belongs into this, what data should go into this partition. It makes the actual routing expression much more simplified. Right? The last example here is, again, for somebody who's only worried about what's happening in the QA environment, you can create a partition just for all data within your QA environment. Like field extraction rules, try to avoid creating partition names and routing expressions that are subject to change. Okay, you'll want to make partitions scale with your data in your organization. Group data that's used together, web logs, OS data, QA environment, right? All examples that I gave you earlier. Don't create overlapping partitions. Avoid, creating a partition where you have, a routing expression of QA, where source category is equal to QA star, and then creating another partition that has a routing expression of QA/web, right? Because this second one is essentially a subset of the first. And we'll get to why that's important in the next slide. Okay, ideally you'll want to use you'll want to create less than 20 partitions in your environment. And that's because when you're not searching across these partitions, there's a little bit of overhead involved in finding all the partitions that exist and trying to extract data from all those partitions. No single partition should exceed 30% of your total daily volume. And if you don't know what your daily volume is, we can help you uncover that by looking at your data volume index. Okay, so if you have this turned on, and you can verify that by going to Manage Account Data Management. If you have this index turned on, you should be able to run a search similar to what I have on screen here, which you could then translate into a pie graph, right? And you can easily see what where my data is going, or where your data is going, right? In this case, 20% of my data is going to a bucket called Others. I don't really care about that. I really care about partitioning the data based off of maybe the three largest buckets here, which is OS Windows, Akamai, and Apache Access. Of course, this will look very different for all of your environments. Okay. Again, the recommended partition size is up to 30%. We also offer an app called Data Volume that you'll be able to install to give you this information and this breakdown based off of source category, collector, and source. Right? So if the type of searches you're doing is not based off of source category, but is based off of collector, or a set of collector names, then you can see the breakdown by collector, so that you can create a good partitioning strategy. So how does search actually use partitions that exist in the environment? Well, let's take a look at what's on screen here. These below are the partitions that exist in this in our sort of fake instance or fake environment. Right, you've got the default partition, which if you did not have any partition set up, all the data would go into this default partitions. But in this case, you have three different partitions that have been created. One thing to note is that the routing expression for partition 1 and partition 3 has overlapping data, right? One is prod star and the other is prod Apache access. This is a no-no. But of course, we have encountered situations where we found partitions in a customer's environment where there was overlapping data. Okay, so take a look at now the, above the sample searches that I've noted, and try to think about what you think will happen when you run these searches. Right, I'll give you, a couple of seconds here to sort of digest all of this information. So if I run a search of star Apache, which partition is the search actually going to look for data? And if I run a search for source category is equal to dev nginx, where in the environment am I going to be looking for data? Okay, so hopefully you guys have answers for each of these sample searches. Well, here's what actually happens. If you run a search for star space Apache, it will actually try to find this data and these keywords across all of these partitions because it doesn't recognize that star, because this is a star search, first of all, right? So it's got to look across all of your data. In the second example, because you're searching for a source category that hasn't been defined in any of the existing partitions, it's also going to be searching through all of your data and all of your partitions. Okay. In the third example, the system is actually smart enough, and this is where sort of query rewriting takes into effect. And we sort of recognize that you have two partitions that include the data that you're looking for. And so we're going to be searching for this data in partition. We're going to be searching for this data in partitions 1 and 3. And that will significantly improve the search performance. But even better is if I, as a user, actually specify the name of the partition itself, then the system for sure will know to only go to that partition, right? So rather than looking through the default partition, partition number 2 and partition number 3, now I'm only searching a subset of my data. And so you can expect a query like this to run significantly faster. Okay? So this is also part of developing good searching habits. If you have partitions set up, use them. Okay, don't always rely on the system itself to rewrite your data. All right. So to call a partition when you're running a search, type in _index equals the partition name. All right, schedule views. So schedule views are very similar to relational database materialized views. For those of you with a database background, that might mean something to you, but essentially it's a static set of results that get created at the time that the view is executed. And these views are executed on a per minute basis, as you'll see in the following slide. Okay. The most common use cases for schedule views is where you want to pre-aggregate your data. And it allows you to retrieve this pre-aggregated data pretty quickly. You can also improve performance for high selectivity queries by using schedule views. And this is an example here where you're looking at a specific set of sources, a specific log file, and keywords that further limit the data. As mentioned, the results are updated every minute, right? And these quasi-materialized views are sort of refreshed on a per minute basis. This allows you to do a long-term trending analysis now that you have sort of this pre-aggregate data. So you can look over the last 30 days to see what was happening in your system. And unlike field extraction rules and partitions, where they sort of take well, not sort of, but they take effect only as the data comes in. You can actually backfill these views, so you can go back, so you can have the query apply the rules for the schedule view for your historical data. So when would you use schedule views? Well, when you have specific aggregate operators that are used heavily in queries, for example, if you're counting the number of errors that have occurred across your messages, um, or if you're summing the number of errors that have occurred across the messages. Another use case is for when data is being trended over a long period of time. If you're doing investigation over the last 30 days to see whether or not the number of failed logins on a critical server has increased, you'd want to use a scheduled view so you can pre-aggregate your data. If you have a highly selective query that doesn't perform very well, you may also want to consider using a schedule view for those as well. And again, my previous example, we took a bunch of source names and metadata tags along with a bunch of keywords that reduced my data significantly. However, there is also a chance that you might be applying other operations to the limited scope that you have that slows performance down a little bit. And in those cases, you may want to you'll want to develop a schedule view with the query that you're using. So these are the recommendations that we have related to schedule views. If you want to time slice your data, meaning if you want to trend your data, use 1-minute time slices. If you use anything broader, think about it, right? When you're going to call this view and actually use it to see data, you're not going to be able to dive into anything finer than the time slices you've created, right? So let's say you've created 1 hour time slices for your scheduled views. You won't be able to see things on a permanent basis. Okay, so use 1-minute time slices. It actually doesn't add any additional overhead for us, and would be beneficial for you. Include aggregation where you see fit. So again, sum and count. Use queries that are not likely to change. You don't want to go back and have to delete these schedule views and recreate them just because the query itself that you're using had or needs to be modified a little bit. So keep that in the back of your head as you're creating these views. Take advantage of existing partitions and FERs. So rather than parsing the data as part of the query in the schedule view, if that data is already parsed, use those pre-extracted fields. Okay, and use partitions as well, because these schedule views basically look at data that has already been ingested. You can actually call a specific index or a specific partition in your query. Okay, include only necessary fields. Again, if you're parsing data inside the schedule view, use the fields operator to limit the result set if you can. And only backfill data that's needed for your analysis. So what are some limitations to be aware of? Well, any data that's being added to schedule views are counted towards your contracted data volume quota. So if you're For those of you who are like a 5 gig plan, right? If you're sending all of your data to a scheduled view, then you're essentially doubling the amount of data ingest that you have, right? So you'll go from 5 gigs to 10 gigs pretty easily. So keep that in mind, which is why I would limit the use for scheduled views to highly selective queries and aggregate results. Any fields that you're parsing within scheduled views also count towards your quota of 200 extracted fields. Okay, so both the extracted fields in scheduled views as well as the extracted fields as part of your field extraction rules are counted towards this limit. Data will only be backfilled through your plan's retention period. Again, everyone who's on this call probably is on a different plan, right? Some of you have paid for 30 days of retention while others may have paid for a full year. Okay, you can only backfill data through the retention period. Okay, as far as what aggregate operators we support, these are the 4 that we support at the moment: difference, num, count, and sum. So if you think about it, you don't want to, average results, because when you want to average the results, when you actually want to do calculations based off of what's in the scheduled view, you're going to be taking averages of averages, right? So in order to avoid that, we just made that operator unsupported. Okay, I know we talked a lot, and this was a pretty lengthy presentation, so let's go and do a quick review of what I've discussed. And then I'm going to open it up to Mario for his demo of a live environment, so you can see these search optimization tools in play. Some of the factors in search performance that we reviewed today are your query structure. So again, be very selective by using keywords and metadata fields to narrow the scope down. So everything before the first pipe in your query string should only include the things that you want to search. Heavy operations like join, transaction, summarize will factor into search performance as well. Again, I'm not trying to stray you guys away from using that. I just want you to be cognizant that not all operations are designed the same way. Your search time range. If you search within the last 24 hours, your performance will be very, very speedy. Possible time zone misconfiguration at the source level can lead to data fragmentation. Remember, review your source setup. Make sure that the timestamps are being parsed correctly. The overall data volume for your account can play a role in this, because if you're sending us over 5 gigs a day, you may want to consider partitions. Speaking of partitions, the use of performance optimization tools, the number of field extraction rules you have set up, the number of partitions that you've created in the system, all play a role in search performance. And lastly, service anomalies. Now we're obviously dependent on AWS. So if one of our nodes or service or instances come down for whatever reason, that'll affect search. And if you're finding that you're getting a bunch of errors, definitely file a support ticket. And we will definitely address the issue as soon as we can. Just note that we do actively monitor search performance and the availability of our service. So it's likely that even if you do file a support ticket, we're already aware of the issue. But don't stray away from letting us know. Okay, so when do you use search optimization tools? Use field extractions when you're parsing the same type of log messages repeatedly. Use scheduled views when you're trying to identify long-term trends, or needing a pre-computer aggregate data. And use partitions where you're segregating data by sort of those metadata tags, and if you're using RBAC filters in your environment. Okay, so this is at a high level. Again, you guys are going to receive copies of this presentation so you can review this at your own leisure. And I know it's a lot of information to take in all at once. And before I hand it over to Mario, I want to stress, the importance of getting some of your partitions and creating a good partitioning strategy. And if you need help building those partitions and creating a good partitioning strategy, reach out to us at at customer-success@sumologic.com. We're here to help. If you find that you have queries that may need a little bit of tuning, send that over to us. We've created this alias optimization at sumologic.com just for that reason. Okay. But if you have any break fix issues related to your environment, continue to throw those into the support channel. All right. Well, I'll hand it over to Mario now. And I'm going to pause the recording. It looks like he took control already.
Thank you, Latimer. Appreciate it. So from the conversation just now, it's obvious that field extraction rules, partition scheduled views are very powerful. And what I want to do in the next 10 minutes or so is just show you some examples of how you can build these. So I hope everybody can see my screen right now. What I'm showing you right now on the screen is an example of a search. Someone put together a quick search. They're going against their source category equals artifactory traffic. They're searching for the word download on every message, and then they go about and build some parse statements. If you notice here, they're parsing for the year, they're parsing for the month, for the day, for the minute, for the direction, file path, and repo, and a few other fields in here, the IP address, and so on. They have a no drop because they want to make sure that if this parse statement doesn't catch what they want, they want to catch it with the next parse statement, and so on. So all in all, you end up having 3 parse statements, which makes it for a fairly lengthy query and also a very intensive query to run. So looks like we lost audio. I hope audio is back. Can someone confirm? Okay, excellent. Looks like audio is back. So what I'm showing you right now is a field extraction rule named artifactory traffic. The scope is for any message that is source category artifactory traffic, easy for me to say. This is the parse statement that I want to run. So if you can remember the query that I had, I'm going to go back to the search query. I pretty much took this and made that a field extraction rule. And what that allows me to do is to make a much simpler query. I can now actually make my query as simple as this, where I say, whenever I find an index artifactory in the source category of same name, I can specify the direction. Why can I do this? Why can I say direction equals download? Well, let me show you a little trick. Since I've already run that field extraction rule and when the data was ingested, now as part of my field browser, with which Latimer showed you earlier, I have all those fields available to me. There's direction, file path, IP address. You notice if I click on any of these, I get a little more information about all the different fields or all the different values that show up for those fields. So under direction, I have upload and download. The cool thing is that now in my searches, if I go back to the search itself, I can say, really, I only care for those messages where direction equals download, and I can make my search a lot easier and get exactly the same data. A couple of things that happen is everybody's using the same standard names or labels for the fields. It makes all our searches a lot easier. Let me show you another example. In this case, I'm trying to find out the startup time for my Tomcat Catalina. So I create a simple query where it says, go into my source category equals Tomcat / Catalina, look for the words server startup, and then do a little bit of parsing in there. On top of that parsing, and I'll let you guys go into parsing at a later time. I'm just showing you here that I do a parsing statement, and on top of that parsing statement, I then do another parsing statement. I take up one of the fields that I had parsed before called message. If you notice somewhere here, I'm parsing the field message. I do additional parsing on that field, and I look for the words server startup in X number of milliseconds. So I take that number of milliseconds and I save it to startup time. I divide it by 1,000, do a little bit of average and all that good stuff. And what I end up is with a nice answer of my average startup time. I can again simplify this a lot better. I'm going to cheat here and just give you the answer right off the bat. But what you're seeing is my query is so much simpler now. And the reason for that is, one, as you can imagine, I created a field extraction rule that says for anything that has a source category Tomcat / Catalina, use this sparse statement. So that allows me to simplify my query and not have the parse. But the second thing I want to point out in here, let me go back to the original query. You notice I was only looking for source category equals Tomcat Catalina. In my new and improved query, I'm actually looking for index equals Tomcat and also source category Catalina. What I did is I created a partition called Tomcat. Let me show you how that was spelled. I'm going to go here into partitions, and there is a partition here called Tomcat that essentially says anything that has a source category equals to Tomcat /star, I want you to make it part of this partition. So notice I gave myself a star to allow myself a little bit of flexibility. If I ever come up with a source category equals Tomcat /errors, it will still fall under this partition. So it's a little bit of flexibility to allow me to grow and build on these partitions. Okay, last but not least, I want to show you an example of a scheduled view. So in this particular case, I am doing, I'm already, because I learned already, I added a partition called Artifactory. So I'm searching my partition Artifactory. I'm searching my source category Artifactory access. And within that, I'm looking for the words accepted login or denied login. Then I'm doing a little bit of parsing statement and pulling out the login status, user IP, and so on. And then I get the results by selecting the fields that I want. I get the results that you're seeing down here at the bottom. This is a great example of how I can use a scheduled view to start inserting these fields into a view as they come into the system. So I'm going to go back in here and show you a scheduled view that I built called Artifactory Logins. Essentially, I want to find out all the logins that are happening. And if you notice, it's pretty close to the query that I had built. And what it's doing is, on a regular basis, it's running this view and it's loading into this view anything that has an accepted login or a denied login, which makes it a lot easier for me because now I can run a search where I say view equals Artifactory Logins, and I can just pull the fields that I want from that particular field. So again, making it a lot easier for me to search against those fields. Excellent. I'm going to turn it back to Latimer. I've been answering most of the questions that came on screen, but if anybody has additional questions, this would be a great time for you to bring them up.
Great. Thanks, Mario. Appreciate it. All right, so I'm going to go ahead and actually stop this recording and turn this into a Q&A session. So I'm going to go look through through the list of questions that I have now. It doesn't look like anyone's asked anything new, but I'll give you a few minutes here to type it out.